Hey everyone, Roy here with Rugged Badger Racing, part of the PartsBadger ChampCar race team. Here with the car, and I wanted to talk a little bit about the flat floor. I talk a little bit about the front section or front aero. Another question we get is about the flat floor because there's not a ton of Miatas that have a flat floor. So let's get started. So we had a bit of an incident in the rear of the car, and I have half the flat floor apart right now. So I got some of the pieces over here, which I'll talk about in a second. As you can see, it's modular. So we have kind of our front section here that goes behind the splitter. You see a little ramp there that's used to cool the transmission. We have a center section here that has two ramps. One is for the transmission, the other is for the differential. The back section of the diffuser here, which you can see that's quite long, and that's one of the ones that was contacted. You can see a duct tape repair there. And then just like a basic side section here. So underneath the car for mounting, I didn't see really any information on how to do this online when I built it. But you can see I have aluminum frames. So here's one rail that goes right next to the pinch weld all the way back. I have a second frame which goes all the way from the front subframe and goes all the way back up the diffuser and actually becomes part of the structure of the diffuser. So we got two of those pieces, 1, 2, and then we have two on the sides, 1, 2 over here. And that's aluminum square channel that we used. I think it's about 1.5 inches. And what that does is it creates a nice mounting structure for the pieces that'll be in the flat floor, and it also extends just below the original box channels. Now the box channels on this car are pretty beat up. It's been a race car a long time, probably hit a bunch of stuff. So anyway, this kind of just extends, keeps the flat floor below all of that. So you can kind of see the structure here, and I use the rev nuts. So they're press fit nuts that you drill a hole, and you use like a rivet gun to compress it, and it's 1/4x20 all the way around. So I have those equally spaced all the way back, and you can see I have one side panel in the midsection of the car. We have the central diffuser piece that goes all the way from there all the way back out the diffuser. We have one on the side, and then the rest has been taken off of the car so far. Now you'll notice we don't have an exhaust because the transmission and differential temperatures, when we had an exhaust up here, even with venting, just way too hot. It's not going to allow you to do a flat floor. For an endurance race application anyway, you might be able to get away with time trial or sprint racing, but for endurance racing, there's just no way the transmission or differential will be able to hold up without active cooling needed with an exhaust in here, no matter how much you wrap it. And then we added the ramps there for additional cooling, which I will show you next. So we'll start with this front section. So the two holes you see up here, those get mounted in the subframe, and it gets mounted along with the splitter over here. So the overlapping, we try to keep it so that the front panel is always down. So the next panel actually goes between the splitter and the car and angles down kind of in a lap type pattern. Just so there's no edges to catch if you were to scrape anything on the bottom, which does happen. But you can actually see part of the oil pan imprinted on this panel. One of the reasons for that is probably because our motor sits maybe 1/4 inch lower than most Miatas. We took out some of the OE mount that was there to get it to sit a little bit lower. And you can see our nice little ramp here. So I try to keep these, I think, around maybe 10, 12 degrees. And you can see this nice little ramp here. So the air can still stay attached to this ramp and create airflow right at the start of the transmission. That's the goal. It actually works out pretty well. And you can see, maybe you can see, when you do have contact on here, these panels hold up pretty well. This is 060 aluminum. I think it's 5052, which is just a more pliable, more workable aluminum. And then we have some 6061 pieces as well. You can see we have 2 diffuser ramps here. Now, part of these diffuser ramps, you can see we actually have part of the old hood frame, which that's all cut out, as you can see there, and it's repurposed. So all of our ramps here are 0 points because we reuse the vertical portion of the ramp as part of the other car. So this is the central piece. We try to keep these aluminum pieces overlapping on the Alumilite pieces, which are here. So this is one of the side sections. See all the marring from jack stands and jacks. This piece got pretty beat up. Now, I did see another video online. I think it's Beavis Motorsports in Australia. He did a flat floor with like 4 mounting holes, I think, or 6, something like that. We have way more than that. And I think it's needed for endurance racing because, I mean, we have heads of screws that just get wore down and fall off. And what's more is, if you think about the way the structure is underneath the car, you're adding rigidity. So all these pieces bolted together, when they're snugged up, you're creating a nice box for the entire car. And although these are fairly thin aluminum channels here and here, and it's quarter 20 hardware, we use grade 8 hardware, they are torqued up into the actual chassis itself and become structural. So if I were to do it again, I'd probably use a thin wall aluminum and actually weld them in place, and still use the rev nuts on the bottom portion. But you know, our first go around, we ended up using aluminum. But I think there's a case to be made for the structural rigidity, boxing this whole bottom portion in. Go right back of the car. We'll take a look at the diffuser. So you can see the diffuser strake is pretty long here. And we have this channel. I think this is still the 060 material here that we use. And then we rivet the plastic portion down to the bottom. And the reason we do that is, you can see here, it scraped and it's melting. So if that happened to metal, we don't want that to bend. So we use a more pliable material. And that strake goes all the way back. And you can see that frame rail here as well, that aluminum rail, which we have some pie cuts in there that we use to create the angle. But that channel connects all the way back here, all the way up to the subframe. And then we have these vertical pieces. And what we're trying to do in the central channel is make the central channel, it's going to be doing most of the work. So we try to make the central channel the biggest and start the furthest forward. Because you can see it's clean air. It's coming all the way. There's no tire obstruction. It's coming all the way from the front of the car straight back. And hopefully we're creating some really nice low pressure right in front of that. And the sides, I'd imagine, are doing less. And you can kind of get a sense from the tire here. So when the tire's mounted, it does come inward a bit. It comes inward all the way to this strake. But what happens is the air doesn't stop there. The air hits the rear tire and it squirts inward. It's called tire squirt. And we're trying to contain it in this channel here. So the tire squirt comes out and basically this channel's done because now we got tire squirt in here. And hopefully this channel's clean. This is our main central channel. And then same thing on this side, which that piece is removed. We try to make these height adjustable, so you can see we got some height adjustment there. We got some height adjustment in the back that we can turn up or turn down the angle. Something unique we did here. I know the common theme is that you want a really nice sharp brake in the rear of the car, but I think Versus Engineering is the company that did some CFD testing and then validated it with wool tufting that air actually stays attached to this much longer than you would think, and we created this smooth ramp up. And it helps enhance enhance the low pressure zone at the throat of the diffuser. And one of the reasons why we have such long strakes, and we did some modifications to try to get this up as high as we could. You actually might be able to see that's where the diffuser oil plugs are. Or I'm sorry, the PPF bolts. So we had a modified PPF that ended up breaking, so we went back to the stock PPF, and we just deal with the bolts sticking out, and we just tape around them. And I can tell that there's a lot of downforce because that tape is pulled tight outward when we get off the track. So there's definitely low pressure being generated on that tape to be pulled downward. So the way diffusers work, it's going to generate all its low pressure at the throat of the diffuser, and we try to get that throat as far forward as you can, so you can kind of see under the car that little bit of tape there and that bolt. That's the throat of the central section, which is basically right by the butt of the driver's seat. That's where we want it, as far forward as we can, because we got this nice big wing in the back that we can balance out the forward downforce. So we want to get the rear downforce there. And then the second piece of this is drag reduction. Diffusers will help with drag so long as the angle isn't too extreme. But it's definitely, with the full flat floor, it's a have your cake and eat it too type situation where you can actually increase downforce and reduce drag all at the same time, so long as you don't get too extreme. So with this diffuser, we'll actually probably be bringing down the angle a bit. It's set up a little bit aggressively, I think, for the high-speed tracks. We also have a side skirt here, which you can see. So one side, I think this side, is the reused bumper. You can kind of see the urethane there. The other side is more of the repurposed hood. Got some blue tape indicating where you can shove a jack into that, and just some tape covering the section so you can actually get a jack under the car. And then that's just bolted into the same channel we used for the flat floor. The side skirts seem to help. We're going to keep those for sure. We had another feature that we placed right here as well to block the bottom of the rear tire, because any air hitting that tire, that rotating tire, creates a lot of drag. We also have, we call them mini splitters, but we kind of have like an aerodynamic splitter arrangement in front of the tire. Not sure if it does a whole lot. I know that this section does a lot. Blocking off the tires so the air doesn't directly hit the face of the tire helps a lot in reducing drag. And then we just added this little section here, hoping for a little bit of downforce because of the high pressure zone on top, and hopefully air is accelerating, still hitting the tire, but less confident on this, really confident on this section here. And that is some of the repurposed package tray, I believe. And I know we were talking about the flat floor. You can see fastback and part of our dovetail here, which I can talk about in a different video. Lastly, I'll talk about the side exhaust and what we ended up doing over there. So the side exhaust comes down here, and this is a lot of work. It's not easy. This is all custom fabricated to get down here, and then the exhaust all along the side. So that's the only way we reasonably thought we could reliably do a flat floor, and that was after having a central exhaust with a flat floor and the temperatures just being out of control. And what we did is the sill, we cut the sill, removed the sill, and flipped it inside out and re-welded it. So instead of being a convex sill, we made it all concave. And this is all the same material that was there before, just re-welded in the opposite direction, hopefully keeping some of the rigidity that was in the original sill, but also allowing for this exhaust to fit. Heat with the driver position has never been an issue. When you think about it, you have the same distance and the same amount of steel between you and the driver on this side as you do in the transmission tunnel. It's actually a little bit worse in the transmission tunnel because it keeps the air there. The exhaust could probably use some wrapping, but that's more so the exhaust stays hot and exhaust flow when it's hot is faster and better for power. This flex pipe has been a huge issue. And we went from braided types, and the braided types, because of the engine movement, would compress internally. And we actually, when we got done with the test session, we had about a 1-inch diameter, internal diameter inside that flex pipe. After our Gingerman race, I think we had 1.25 inches inside that flex pipe. So we moved to a bellows style, and it's actually working out really well. The only abrasion you see here is when we were doing some tire testing and moving the car around, we hit it against the tire. But it's actually never contacted it during racing, and we actually haven't had any temperature issues with the front tire there either. The biggest issue is, so we have a slightly modified OE header here. We shortened up the distance here, and then we created this custom mid pipe so we could go out the side. But you can see this chain. We have one here. We actually added one to the other side because running the OE mounts, this engine moves a lot. And when the engine moves, you're flexing that entire exhaust section, and all of that flex goes into this poor little flex pipe and creates a lot of strain. So this is an important piece. Adding the chain was a big help. We had success. Think about, we got 8, maybe 10 hours of track time with the chain and this exhaust setup, and finally I think we've got it debugged. We also have really good control over our transmission and differential temperatures this way. And then with these vents, which we'll probably actually test blocking some of these as well, because I do think that this, initially I thought that they would be increasing downforce. I think they're actually reducing some of the underbody downforce, even though they are ramps. So important part of the flat floor, how do you control the heat? But here are the panels again, so you can get an idea there. And then the aluminolite is 1/4 inch aluminolite, or 6 millimeter, I think, aluminolite, and then 060 aluminum for the other panels. You could probably get away with slightly thinner, but these have held up generally well. So you saw our flat floor and the work we went through to put that together. The side exhaust, cutting apart the sill, flipping the sill, re-welding that, all of the learning curve that takes place with making the exhaust reliable now that you're not using something off the shelf. And I think at the end of the day, I don't think it was worth it. At the higher speed tracks, I think it matters more. From a downforce perspective, real early on when we did the first flat floor before moving to the side exhaust, the testing that we had, it felt like there was a substantial difference in downforce. You could really feel it. It was very unstable because you would hit a rumble strip and all that downforce would go away. That was Road Atlanta 2020 when we first had that without the side exhaust. Initial testing, just the temperatures for the transmission and differential weren't sustainable, and we removed the full central panel for that race. That's the only way that we'd be able to race, is if we did that in order to control the heat. And when we did that, the notice, there was not a significant noticeable difference in downforce versus the non-flat floor. So from a downforce perspective, I don't think there's going to be a huge difference, especially at slower speed tracks, or even high speed tracks with slow corners. A bigger difference, I think, would come from maybe drag reduction. And that's one of the things that I noticed. We're not the highest horsepower team. We're running like 148, 145 at the wheels. Not an insane amount of torque. But we can keep up with cars that have supposedly a lot more power, or should be faster cars. And on those straightaways, we don't lose them. And I think part of that is just our car's a lot slipperier. And I think, yeah, we got the dovetail, we got the fastback. I know that makes a really big difference. But I think the flat floor to the diffuser helps that a lot as well. And maybe we're making up, a couple horsepower, maybe a handful of horsepower, just in overall drag reduction versus a stock body, non-flat floor Miata, which kind of makes up that delta. So Doing it again, I'm not sure if I would. I think I would focus the time and attention on somewhere else, just because we didn't see those massive gains that we initially expected. But that's my summary on the flat floor. Obviously, everybody has their own choice, you know, and going with the stock exhaust route, especially if you have short races, you could get away with it, because that's the big pain in the butt. So if you can do it without doing a side exhaust, then yeah, I think it would flip it to make it worth it. Thanks, guys.